Alright, so in this video I'm going to be taking a look at finding the nature of a stationary point. Now you'll remember a stationary point can also be thought of as a turning point. And here's our pilot piloting his plane going up and down across time, across those 30 seconds. He's got turning points here and here. Now if you watched the previous video, if I can call that up, you'll remember that those turning points were taking place at 25 seconds and at 8 1/3 seconds. Now, it's really simple. When I say find the nature of a stationary point, we've got three different types of stationary points we can have. We could have a stationary point that looks like this. That's called a maximum. Goes up to a point, comes back down, so it's a maximum. We can also have these. That's called a minimum. So you can see this is a maximum and this is a minimum. We also have these. Comes up, stops for a moment and starts going up again. That's called an inflection point. Now we knew the function. We also had a drawing of it, so we know that that's a maximum and we know that that's a minimum. But sometimes you don't have the luxury of having the drawing. Sometimes the function is too complicated for you to draw, in which case you're going to have to be able to figure out whether something's a maximum or a minimum or an inflection point by doing it by hand. A bunch of algebra to determine that yes, this is a maximum, yes, this is a minimum. So we know what they are, but we're going to do some mathematics to confirm it. To do that, we're going to create a little table. Alright, so here's my little table. Now, I don't need to really put that there. So, this is my turning point, and this is the drawing I'm going to draw. Here's what's happening at the turning point. Here's what's happening before the turning point. Here's what's happening after the turning point. It's going to make a little more sense in a minute. So we're going to focus on this turning point, 8 1/3, which is 25/3. I'm just going to do it in a fraction here, it makes my life easier. So we're testing our first turning point, which is 25/3. We're going to find out whether it's a maximum or a minimum. Now, we know that at the turning point, the gradient is 0. At all turning points, the gradient is 0. We actually calculated that over here. Gradient is equal to 0. The turning point is at 8.33. Now, what about just before the turning point? So I'm going to here's my function, f of x equals 4x cubed. Now I'm going to find the derivative of that. You've done this a million times. And the question really is, what's the gradient over here? Just a little bit to the left of my turning point. So I'm going to sub 8 for x into f dash x. Now I type that into my calculator and get an answer of 68. So before the turning point, the gradient is 68. Now it doesn't really matter what that number is. The question is it positive or negative? It's positive. Big plus sign. Turning point, it is 0. And after the turning point, well, I'm using 8 1/3 here. So if I want to test after the turning point, I can use like 8.5. And the answer is negative 33. So after the turning point, negative 33. I don't really care about the number. What's important is the negative sign. So positive sign, 0, negative sign. This was where I tested it at number 8. This was the turning point at 8 1/3. This was after the turning point at 8.5. Now, drawing this, a positive gradient looks like this. A 0 gradient looks like this. And a negative gradient looks like this. Bring them all together. Boom, boom, boom. Bam. Maximum. So what we've just done here is find the nature of that stationary point, 8 1/3, positive before the turning point, 0 at the turning point, after the turning point, it's on the downward slope, therefore it is a maximum. Now I can obviously go one step further here and find the nature of my turning point. I can go one step further here by finding the nature of this turning point. You already know it's a minimum, but we can test it by subbing in 25, so that would be f dash 25. Here we do f dash 24.5. Try to keep your numbers close to that number. You can even do like 24.9 or something like that. And then here f dash of, I can do 25.1. Doesn't really matter as long as one's to the right of it and one's to the left of it. Now when I do that, I'm going to get a negative answer here. At the turning point I get a 0 answer, and after the turning point I get a positive answer. You can try it if you want, but I can tell you that's what's going to happen. Draw it. Negative gradients look like this, 0 gradients look like this, and positive gradients look like this. Put them all together, boom, boom, boom. Boom. It's a minimum. Now there are sort of 4 ways these graphs can go. Maximum, minimum. It can also go bump, bump, bump. That would be an inflection point, where that's not a very good drawing of an inflection point. And obviously they can go the other way as well. Bump, 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 inflection point. Alright, so 4 different stationary points. You test them very, very simply. Find the turning point, then test a little bit to the left, test a little bit to the right, draw a picture, job done.